because you want only a single manager of all these 10 threads, so that your entire system can manage all the threads in a efficient way. Let's say there are 2 thread pools which are managing these 10 threads. So what kind of problems can happen? Hi all, this is me Karan. So in this particular lecture we are going to talk about singleton design pattern. What is the overall idea behind using singleton design pattern, and what kind of problems we can solve using singleton design pattern. So we'll try to understand all these things in this particular lecture, and in the next lecture we'll try to implement one of the problem statements where we'll be trying to solve one problem using singleton design pattern, and then I'll provide you some of the sample problem statements which you can use to increase your understanding around singleton design pattern. But before starting the lecture, I would like to mention a few things. If you are not aware of what is copy constructor, why do we need to delete default copy constructor or default constructor, or what are the static functions, so please try going through them before jumping into this particular lecture, because we will use different concepts around constructor, copy constructor, delete, static functions while understanding the singleton design pattern. So let's try to understand in what kind of problems we generally use singleton design pattern. So first let's try to understand in what kind of problems we use singleton design pattern. So sometimes what happens is, let's say there is this class X in your system, and this class can contain different functions or member variables like that. So what you want is, you want the single instance of this class X in your entire system. So let's say you have created the object X obj, so there should be only this particular object in the whole system. Let's say now next user try to create the object of this class X and obj1, then system should not allow this, because this particular object is already there and you are trying to create another object which will break the singleton design pattern rule. That is, at a time in the whole system only single instance of this particular class should exist. So in what kind of problems we generally use this? So let's say you have a logger inside your system which will log different events. So what you want to log everything using the single instance of this particular logger. So let's say you create the instance of this logger log instance, then everything should get logged using this particular instance only. There should not be like you are creating another instance, log instance 2, and then you are trying to log something using this particular instance. And what is the reasoning behind that? Let's say there is one particular log statement, log something, and there is another particular statement, log second log. Let's say this particular statement gets executed at time t and this statement executes at time t plus 1. So ideally what should happen is, this particular log statement should get logged first in the log file, and then this should log later at this particular line. But it might happen that this particular log instance was busy in doing some task or updating the file, but this particular instance, log instance 2, updated this particular log inside the log file first. So what happened is, second log got logged here, and then this log got logged at a later point in time by this particular instance. So ideally what should have happened is, this particular log which came at time t should get logged first, and then this particular log should get logged. But because there were multiple instances inside our system of this logger, so that's why this log which came at a later point in time got logged first, and then this particular log which was supposed to get logged first got logged second. So this is one of the problems where we can use singleton design pattern. So there can be another problems as well. For example, let's say there is thread pool inside your system. So let's say this is class thread pool, and this class is responsible to manage different threads inside the system. So let's say this class manages 10 threads. So what you want is you want the single instance of this particular class inside the entire system. Why? Because you want only a single manager of all these 10 threads, so that your entire system can manage all the threads in a efficient way. Let's say there are two thread pools which are managing these 10 threads. So what kind of problems can happen? So let's say there is one instance T1 of this thread pool, and there is another instance T2 of this thread pool, and this is also managing these 10 threads, and this is also managing these 10 threads. So it might happen that it is managing threads according to some logic. So this is also trying to manage same threads using same logic. So conflict can happen and our system will not perform well. So another example if I take is, for example, let's say database connection. So what happens is database connection is a very expensive operation. Like when you try to connect to the database, you make connection. So what happens is, let's say there is some request 1. So when first request will come, at that time you will create the instance of this database, let's say DB instance, and let's say second request comes, then you won't create another instance of DB connection because this is a very expensive operation. Instead, you will use the existing DB instance itself to fulfill the requirement for this particular request too. So again, this particular instance will get used. So that way, only single instance of database connection will be there in your entire system. If it's a first request, at that time you can try creating the instance of this, and during the execution of your program, this instance will get used all the time. So overall, if I say, whenever you want the single instance of any class inside the whole system, then in that scenario you are supposed to use singleton design pattern. So we'll try to implement all this idea, like how we can make sure that only single instance is there inside the system, all those things in C++ in the next lecture. Thank you.